Jai Hind viewers, myself Dr. Sukhwinder Singh Dhillon. I am working as Associate Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss what is the working principle and construction of single phase synchronous motor. It is basically an induction motor, but it runs at speed of synchronous. Okay. And first motor we are going to discuss, that is reluctance motor. Okay, what is reluctance motor? What is reluctance actually? If we want to discuss reluctance, as we have discussed in the first lecture, that what are the magnetic quantities, okay, and what is reluctance? We have already discussed in the magnetic circuit what is reluctance. Reluctance is can be defined as opposition to flow of magnetic flux. Okay. And the concept behind the reluctance motor is, suppose we have bar magnet north and south, and nearby this we have any ferromagnetic material or magnetic material. What will happen? Due to the magnetic lines of forces, its dipoles gets aligned in such a way, so that north is here, south is here. Okay. Because of this permanent magnet, this magnetic material which is maybe paramagnetic or ferromagnetic, para or ferro, okay, gets magnetized so as to develop a force, that is force of attraction between these two. Permanent magnet, this one is magnetized, okay, with the help of this one, and due to the magnetization of this ferromagnetic material, it induces north and south like this. Now, there is a force of attraction between these two, and this force, this attraction force will move the magnetic material bar, magnetic material or soft iron bar. Let me erase this. Bar near to the magnet, okay, so as to reduce the reluctance offered by the air gap between these two. Okay. Due to this permanent magnet, what will happen? This bar or magnetic material bar get magnetized in such a way, there is a force between these two, which is force of attraction. That force will tends to move this magnet, or it will go to this side, or this will go to this side according to the weight of these two bar. Okay. And they will occupy the minimum reluctance between these two magnets. Okay. One is magnetized and one is permanent magnet. So as to reduce the air gap, they will force each other to occupy the minimum reluctance position. Okay. And suppose we have a permanent magnet, this one is bar, soft iron bar. When we close these two, then there is a force of attraction. Okay. That force of attraction tends to move this bar magnet, or this permanent magnet may also move towards to this soft iron, so as to minimize the air gap between these two. This force is responsible to reduce the air gap, so as to reduce the reluctance offered by the air gap. Okay. To flow the flux, reluctance formula S is 1 by mu naught into mu r L by A. Okay. This is the reluctance formula, and based on this principle we have the reluctance motor, and that reluctance motor runs at synchronous speed. As we have already discussed in our previous lectures, from the beginning of induction motor, single phase induction motor, that induction motor can't catch up the speed of synchronous. It always remains below the speed of the synchronous. Okay. But in this case, in this special type, we have the reluctance torque, okay, developed on the rotors. So, on the basis of this mechanism, this minimization of the air gap, because rotor, suppose this is the rotor part and this is the stationary permanent magnet part, and this will try to align itself, okay, so as to minimize the air gap. Okay. And we can say so as to reduce the reluctance offered by this air gap between these two. Understood? Now, by following this mechanism, how we can make this a reluctance motor? Reluctance motor, construction wise, it is almost similar to the induction motor. First of all, we are going to discuss construction. I can write reluctance motor is a synchronous motor, but single phase, okay, based on the principle of reluctance offered by the rotor to stator. What kind of construction we have so as to follow this reluctance torque phenomena? Construction wise, on the stator side, of reluctance motor, there is no change. It is similar to single phase induction motor having two windings such as auxiliary winding and running winding or main winding, auxiliary winding, starting winding and main winding, similar to the single phase induction motor. It also having two windings auxiliary winding as well as main winding. Suppose this is our stator winding and this one is the main winding. And in parallel to this is auxiliary winding, okay. See, on the rotor side which is also a squirrel cage type, but the only difference between the simple single phase induction motor and reluctance motor is that its rotor construction is modified in such a way so as to have the variable reluctance phenomena. It offers variable reluctance phenomena. How? See here, in this construction of rotor circuit, what we have is, let me erase this one because space is, see here, suppose this is our rotor circuit and some of the slots from the rotor circuit are removed so as to have salient pole type construction. See what kind of modification we have done in this rotor circuit so as to have the variable reluctance phenomena, so that it offers variable reluctance phenomena. See here, similar to the induction cage rotor, its rotors bar are short circuited on either ends. This is salient 4 pole salient type cage rotor having variable reluctance characteristics. Okay, variable reluctance characteristics. Why it is variable? Because if we see at the pole face of the salient pole with respect to stator, see the air gap between stator and rotor at the pole face is minimum. See here, if we see from this pole face with respect to the stator, suppose I am making this stator like this, the air gap between these stator and rotor part is minimum, but in between two salient poles this air gap between stator and rotor part is large. Okay. At the pole faces is minimum and the air gap between stator and rotor part other than pole phase position other than pole phase position is large. Now, we have the variable reluctance offered by the rotor to the stator. Okay. Here we have the variable reluctance rotor offered by the rotor circuit. Now, how it works? See, kindly consider all the points very carefully or listen all the points very carefully, so as to understand the working of this reluctance motor. At starting, what we are doing, both main and starting or auxiliary windings are in the circuit to develop required starting torque. Similar to, there is no change, similar to the simple or similar to the simple induction motor working. See, at starting there is no problem, both the starting and main windings are in the circuit to develop the required torque. Okay. Starting torque similar to the simple induction motor working, as we have discussed in the previous lectures. Okay. Now, listen carefully, when rotor speed reaches to its 78% of full or normal speed, 70% of normal rated speed. Normal rated speed, what will happen? Centrifugal switch as in the case, as similar to resistance start, capacitor start and inductor start. Induction motors we have already discussed as similar to the resistance start, capacitor start and induction start motors. Okay. Centrifugal switch will cut down the starting winding, okay, and motor now motor speed is taken care by the main winding now, and motor speed is maintained by the main winding. Okay, main winding only. Up to this point there is no change with respect to the other induction motors. Now, why we call this motor running at synchronous speed? As we know that synchronous speed ns is equals to 120 f by p. Suppose we have 4 pole motor reluctance type, okay. Then ns at 50 hertz frequency, it comes out to 120 into 50 by 4, it comes out to be 1500 rpm. Okay. See, this reluctance motor will run at this 1500 speed as compared to other induction motors whose speed under normal running condition is always less than the synchronous speed. Okay. Now, what will happen when motor speed is near to the synchronous speed, or we can say slip becomes 0. If it attains synchronous speed, slip becomes 0. Okay. Now, if slip is 0, rotor induced voltage is 0, IR rotor induced current is 0, then induction torque is 0. All the things are 0 at synchronous speed. When motor speed is near to the synchronous speed, or I am taking the example of that slip is equal to 0, that rotor has attained the synchronous speed. But what will happen now? Okay. When there is no current, there is no induction torque is here, how this speed is maintained? Okay. See, when this condition is attained, that induction torque is 0, immediately reluctance torque will develop and rotor will lock itself with the synchronously running stator's flux. Okay. What will happen when there is no induced in voltage in the rotor circuit? IR is 0, induction torque is 0. Now, what the thing is present in the motor so as to maintain its speed at its synchronous speed? Okay. This is just because of that variable reluctance offered by the rotor circuit, rotor position with respect to the stator. As I have already told in the previous slide, by following this concept, rotor wants to catch up the speed with this. Okay. This synchronously moving flux will attract this iron piece in such a way so as to reduce the reluctance. Okay. And in our case, when there is no induced voltage IR 0, there is no rotor flux, even there is no rotor flux. Okay. And we have to suppose that rotor iron is running near to the synchronous speed, and due to this salient pole construction or due to this variable reluctance, the poles, these 4 poles are attracted in such a way so as to align them at minimum reluctance pass with respect to the stator's synchronously moving flux. Because what will happen here? We have the rotor, we can't say we have this these are the induced poles, but here we have or induction torque. This is north and suppose this is south. North and south of the stator flux are running at synchronous speed, okay, and due to variable reluctance offered by the rotor to stator flux, rotor wants to, let me raise this, rotor will try to catch the speed of stator's flux, and the force or the torque, torque developed by on the rotor, is known as reluctance torque. Torque developed on the rotor is known as reluctance torque, okay, reluctance torque. This is all about the how this motor catch up the speed at synchronous. As I discussed from the starting, it runs with the starting and main winding, both are in the circuit, and it will develop the required torque to rotate the rotor similar to the other induction motors. As the motor pick up the speed and catches the speed of near to 78% of its normal speed, now the centrifugal switch will cut down the supply of the starting winding, and with the help of running winding it will maintain the speed. As it approaches to near to the synchronous speed, what will happen at any instant, due to this variable reluctance offered by the rotor circuit, this flux, it is also running at synchronous speed, this rotor is running at synchronous speed. As it approaches to synchronous speed, induction torque is 0, no problem, induction torque is 0, but the another torque will develop due to this variable reluctance, so that it will make the lock with the stator running flux, okay, and that torque will able to maintain its speed at synchronous speed. This is all about the working principle of reluctance motor. Now, if we want to discuss the torque speed characteristics of the reluctance motor, okay, see here, this side we have on the y axis it is torque, here we have the slip 1, then we have the slip 0, this is the slip variation, okay, and speed of the rotor is 0 here near the ns. At the starting, as I have discussed, 300 to 400% of the full load torque developed by this starting and main winding, this torque is developed like this. Okay. When it reaches to this, torque is developed with the help of both starting or auxiliary winding plus main winding. Okay. And if we follow the main winding only, then its torque curve is like this. For main winding, we have already know how its torque curve is. Rather than at synchronous speed, what will happen? Starting and main winding, we have the torque, and this is the main winding torque actually. This is main winding only. When centrifugal switch operate from here, it moves on to the main winding. Okay. After this, torque is directly proportional to slip, it follows like this. Okay. At this point, when the speed is synchronous, see here, so let us suppose this is A point. At A, rotor speed is synchronous speed, but how this speed is maintained? At this point, what will happen? After this torque, main winding torque induced on the rotor circuit becomes 0. Why it is 0? Because slip becomes 0, then induction motor torque becomes 0. With the help of starting and main, we have start the motor at 78% of its full speed. Then it shift with the help of centrifugal switch to the main winding torque, and main winding torque, we know that under running condition, after the maximum torque condition, torque is directly proportional to slip, and it start decreasing as the slip approaches to 0. At slip approaches to 0, NR is equal to NS, but at this condition what will happen? This main winding torque, which is induction torque, is also 0, but due to reluctance, this is the full load torque of the reluctance motor to maintain the speed of motor at synchronous speed. Main winding torque is 0, but this portion is not 0. From suppose this is our B point. Okay. For this particular length from A to B, this is the magnitude of the torque, and this is known as the reluctance torque, not the induction torque. At synchronous speed, it becomes 0. It does not follow the induction motor phenomena. After attaining the speed of synchronous speed, the whole induced torque with the help of current or with the rotor flux becomes 0, nothing, but this is the force of attraction produced by the stator flux, so as to make the lock of that iron with respect to with itself. Okay. So as to maintain the speed of the rotor at the synchronous speed. This is all about the working as well as torque speed characteristics of reluctance motor. Okay. This motor is also used for light loads. Okay. Thank you so much for watching the video. Thanks.